Hello everyone, Aaron here and welcome back to Leetcode. Today we are doing the continuous subarray sum problem. I put strange emphasis on that. Given an integer array nums and an integer k, return true if nums has a continuous subarray of size at least 2 whose elements sum up to a multiple of k, or false otherwise. An integer is a multiple of k if there exists an integer n such that x equals n times k. 0 is always a multiple of k. Okay. So here, for example, 23 is not a multiple of 6. 2 is not a multiple of 6. 4 is not a multiple of 6. 6 is a multiple of 6. 7 is not a multiple of 6. The 2 and 4 together do make a multiple of 6. They make 6. So the 6 by itself wouldn't count because we need a subarray size of at least 2. So this passes. This one here also works because again we can't have the 2, 4 this time because they're not next to each other. They need to be a continuous subarray. Sometimes called a subsequence, I guess. But if we take all of them together, let's see, they're a multiple of the 2 and the 4 are a multiple of 6, the 6 is a multiple of 6, and the 23, if we add 7, gets to 30, which is a multiple of 6. So yes, the overall thing is a multiple of 6. This one here, 23, even if we add 2, that's still not a multiple of 6. We're aiming for 13. 13, 26. No, I don't think we're going to be able to get there. 39. No. So yeah, we just can't do it with this one here to get to a multiple of 13. Right. My immediate thought is this is another dynamic programming problem. So I think I said this in a previous video, dynamic programming problems are not my strong suit, but let's give it a go. So we're basically always trying to check mod, okay. If I'm looking at the 23, I can either try and continue using it, or I can skip it. So basically what we're trying to do is we're trying to work out what two integers that are at least 2 apart. So one way to look at this is if we've got I and j for, let's call them beginning and end, B and E. 0, 1, 2, 3, 4, 5. Hang on, 0, 1, 2, 3, 4. And we can start at, space this out a little bit, we can start at 0, 1, 2, 3, 4. Now obviously we don't need to do the whole thing because we need at least 2. We have to end at least index 1, taking 0 and 1. And we can't end at 4, we have to end it at most 3 to take 3 and 4. So, to fill in the diagonal, actually no, you know what I'm going to do? I'm going to put those back, because to fill in the diagonal, starting at 0, ending at 0, that's just 23. Starting at 1, ending at 1, that's just 2. Starting at 2, ending at 2, that's just 6. 4. Sorry, 2, 4, 6, 7. 2, 4, 6, 7. So we can fill in that diagonal quite nicely. And then we only need to fill up the upper triangle of this matrix now. because starting at 1 and finishing at 0 is undefined. So this one here, if I do 23 plus 2, that's going to be 25. I probably need to space these out even more, didn't I? Then this one here is going to be 2 plus 4, which is 6. Oh, it's the addition of those two things below it. So this one here is going to be 10. In fact, we've already found this one now, so this is done. We can call that one finished. But if we wanted to finish building the table, this is going to be 6 plus 7, which is 13. This one here is going to be a 25. Is that a 25 plus a 6? 0. No, it's not a 25 plus a 6. Why is that looking like it should be a 25 plus a 6? This should be a 25 plus 4. Oh, it's that plus its columns value, isn't it? 29. Plus 6 is going to be 35. Plus 7 is going to be 42. Again, we don't need to do this just because we're done, but I'm just going to work out the exact algorithm here. So this should be 6 plus 6. 12. Yeah, that's correct. Okay, so that's the algorithm I think we're trying to do, isn't it? Or is that too slow? Okay. If len nums is less than 2, return false. Table is going to be, let's just build the whole table. It's going to be the singleton containing num times len nums for in range len nums. In case you've not seen this before, the reason I'm not... So what looks like should be an easy way to do this is none times len nums times len nums. That doesn't work because in Python lists are mutable, and this creates a reference to the same list inside the list many times. If you sort of think about it visually, it's a list of pointers all to the same thing. And that means if I mutate one of these lists, I'm mutating all of the lists. Whereas if I do it this way, I generate a new list of nones for every element, which is what I want, not the same list copied many times. So that's why it's a slightly funny incantation. Then it is for I in range len nums table I is equal to nums I. So now we've set up the diagonal that I talked about. In fact, I probably don't even want to do that diagonal, do I? I think those are better off being empty. Yeah, I'm actually going to change that. For begin, let's call it B in range len nums minus 1, because we don't want to do the last thing. For E in range B plus 1 len nums. So So this is, I don't want to start at 0, 0, I want to start at 0, 1. I don't want to start at 1, 1, I want to start at 1, 2, so on and so forth. If table B E minus 1 is none. That's why I should have done the diagonal. Anyway. No, let's do it now. High in range length nums. Table I is equal to nums I. Right, so that does put the diagonal back. And I just got rid of it. 23, 2, 4, 6, 7. So it's going to be table B, not 3, E is equal to nums E plus table B E minus 1. If table B E mod K is equal to 0, return true, return false. So do we actually need to memorize this? Because I never look up in the table. That might simplify things quite dramatically. Let's try this again. Let's run this code and see if it actually works before we try and refactor it. Good. Use all the example test cases. Looking good. You know what? Let's solve all the bugs. Or cause all the bugs. False is not defined. Did you mean false? Yes, I did. Thank you very much. Should have caught that one in testing, not in production, but there we go. Little slow. Time limit exceeded. Okay. Can I know? No, I can't know a priori whether... Because there could be something up ahead that I can just add to make up the difference. Maybe I can go the other way. If I know the sum is not a multiple of 6, I end up with the same kind of problem. I just need to choose whether I drop the left or the right at every step, and I have to try every possible dropping of all the lefts and the rights. Let's try this without a table. So prev is nums B. Prev is nums E plus equals nums E. Prev mod K is equal to 0, return true. Okay, let's see if that's any faster. Obviously, it's still going to pass these tests. Let's try doing this test. That worked. Could have worked previously. It might just be when it's done with everything else it's too slow. But we did remove a lot of memory manipulation and creating lists, so it should be a little bit faster overall. Not asymptotically faster. Like we haven't moved down a complexity. So we've still got problems. So we still need to go faster. Give me this one. Ooh, that is a big test case. Copy. Paste. Ooh, did that take everything? Yeah, it did. It's just not showing correctly. Right. This should time out. Hopefully. Yeah. Is it faster to do addition with little numbers? No, I can't do that. I was about to say what I could do is just take all of them mod k. Because a mod k plus b mod k is that... Hang on, so my thinking here is we don't need this anymore, I don't think. A mod k plus b mod k, is that equal to a plus b mod k? This is xk plus a plus yk plus b is equal to x plus y k plus a plus b, and if I take all of that, that's going to be xk is going to go to 0, so we're going to get a mod k plus yk is going to go to 0. Ooh, hang on. Yes, I need to be looking at this. This all mod k, this term is going to be 0, so that's 8. So that is correct. So what I can do is just take mod 6 of all of these. For I in range len nums, nums I is nums I mod k. And then the addition, that can also be done here, mod k. I'm fairly sure that's correct. I'm a little unsure because modular arithmetic can be remarkably unintuitive. But no, that's correct. I'm sure that's correct. Yeah. Let's see if that's made things any faster. In fact, I don't even need to do this mod here anymore. That can just be a straight equals to 0. Because now it's all much smaller numbers. Is that better? I don't know. Time limit still exceeded. Okay. The problem I'm having is, how do I know to say discard the 23 here? Because although I pick up the 2 and the 4, I don't necessarily know yet that this is a bad option to take. How can I reject this test case more quickly? That's what I don't quite understand. No, sorry, I'm being slow. I'm not I'm not quite seeing what I need to do here. Because I'm just having a thought here. So back to this table that we had earlier. This was what? Beginning and 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Yep. 0, 1, 2, 3, 4. So we started at 0, 1 with a 23, and then we went here with a 25, was it? Yeah. And then we went here with a 29. 0, 1, 2, 3, 4. Hang on. No, sorry. We started with the 25. Then we went to the 29. Then we went to the 30. 35. And then we went to the 42. So here, this would bail us out. There. We could immediately say that's done. But I'm wondering if we go here, what we want to do is we want to just subtract $23 from it. Is that correct? So that's going to end us up with, no, it's not correct. No, 29 minus 23. That is what we want to do. So that's 6. Here we want to do 20. No, that's not what we want to do. Is this 35 minus 23 again? Yes, it is. 35 minus 23 is 12. Yes, and that's correct. So that's 2 plus 4 plus 6. So here we want to do 42 minus 23. Okay. 19, which is correct, which is 2 plus 4 plus 6 plus 7. Then this one here, I want to do 12 minus 4, 8, because that's 4. No, what is that? No, I want to subtract 2, 10. Because then because that's the 4 plus 6. Okay, so it's the recurrence here is if b equals 0, t. No, hang on, it's just more straightforward than that. If t 0, e t01 is equal to nums 0 plus nums 1. T0 e is t0 e minus 1 plus nums e. This one here. So 0, 2, for example, is t0, 1, 25 plus 4. Yes. T b e is equal to t b b plus was t b minus 1 e, because it's that number, minus nums e minus 2. How is this an improvement over what we had before? This feels like just a more complicated version of the same thing. This is no more efficient than what we've got here, because I still have to go over the beginning and the end. This is just a more complicated formula of the same thing. So that's not really helpful. The reason I thought it might be helpful is here I'm kind of re-adding things a lot. So I take this number, and then this number I need to get from that, and then this number I need to get from that, and then this number I need to get from that, and this number here, well, that comes for free, then this number I need to get that. But I've already got it. That's the thing. It's not like I'm having to recompute it, and that's this number here. I either need this or I need this. I can't just magic it out of nowhere. So I need to shrink this table. What am I doing here? It's a window of unknown size, but I do not know. It's the unknown size problem that I'm struggling to slide. So I grow the window, but how do I know when to stop growing the window? I don't. I do not know when to stop growing the window. So this is the wrong way to think about this problem. This is what I'm kind of learning. How can I know 2, 4? Or more accurately, how can I know the 2, 3 is not involved? Because the 2, 3 can be involved. Because that there is a subarray. It's the entire thing, but it works. The problem is, basically what I'm doing is I'm adding up all of these. Then I'm adding up, then I'm saying, well, that didn't work. So let's add up all of these. And let's add up all of these, and let's add up all of these. It'd be much nicer if I could slide this somehow. And so I've added up those. But that's not worked, so I need to take in something, but... What is 23 mod 6? 5, isn't it? This is 5 mod 6. So when I take in the 2, we're at 1 mod 6. Then I take in the 4, we're at 5 mod 6. So there's something there with the tail. I got to 5 mod 6 and my start was 5 mod 6. So it's worth dropping. But why did I know that? So 5, 1, 1. No, let's go this again. 5, 1, 5. It's because I've seen this 5 before, isn't it? Is that the trick I need to somehow generalize? If the mod sum I'm building up I don't see how to generalize this, that's the problem. Because if I take these 3, I can say there's a prefix of this with the same mod sum as what I'm currently got. But how do I know when to drop things from that? Or is that enough? So hang on, my prefix sum here is 0. Let's try this algorithm. This is useless, so let's try this. So first off, I'm going to convert these into 5, 2, 4, 0, 1. These are the mod values of nums. So now I'm going to do 5 with an empty list. There are an empty set. There are no prefix sums available. Now I'm going to do 1 with the 5 prefix available to me. Now I'm going to do yeah, because that's 5 plus 2 equals 1. 5 plus 2 equals 1. Put the 5 in there. Now I want to do 1 plus 4 equals 5. And I'm going to have 5 and 1 in my prefix set. And that 5 means I have a sum. That might do it. So if we do that here for this next one, this is 52047. So this is 5 empty. Then it goes to 5 plus 2 equals 1 with the 5 in there. 1 plus 0 equals 1. The 5 and the 1 in there. 1 plus 4 is equal to 5. And I did throw the 1 in, but it's a set, so it doesn't get duplicated. Ooh, that doesn't seem right. Why? I'm now saying that's good enough. Why am I saying that's good enough? Oh, because that is good enough. 2 plus 4 plus 6. Ooh, no, that's 16. I can't do this modding first. That's... Well, that's bad. Let's remove all of this mod apart from there. That's a danger. Right, so let's revert this to 23 2 4 let's look at 23 2 4 6 7. So the first sum is 23. That's not right, and we're going to put 5 in our set still. Now I'm going to do 23 plus 20. 23 plus 2, which is 25. I'm going to put, oops, no, there's actually nothing in there, and I'm going to put 5 in. 25 plus 4 is 29, and the 25 had a 1 mod 6, and 29 is 5 mod 6, so we still stop. So I might put in parentheses what its mod value is. So if we do that again here, now I want 23, 2, 6, 4, 7. Let's remove this. So I'm going to do 23, 5 with the empty set. Then I'm going to do 25, 1 with the set with a 5 in it. Then I'm going to do 31, which is 1 with the 5 and the 1 in it. Ooh. That would also be a stop condition, because that would tell me I could drop both of those. Oh, because the 6 is telling me it's valid. Oh, bollocks. So yes, it's told me that I've come across something that is potentially right. Problem is, I also need to keep track of how far through I am and how far through I was when I added this sum. I was at 0, I was at 0, I was at 1, here I'm at 0, here I'm at 1, here I'm at 2, 2 minus 1 is not greater than 2. So then I want to go to 3, I want to keep adding, so this is 31 plus 4, which is 35, which mod 5 is mod 6 is a 5, so I'm going to add a 5, add a 0, 5, is 1, add a 1, 1, 2, oh god, that's not good, those need to be arrays, sorry. 0, 1, at 0 and 3. Oops, no, just at 0. 1 is at 1, 2. 4 is 35 plus 7, which is 42, which is, 0. So what I maybe want to start with is a 0 living at -1. Because the first number, yeah, that's what I want to do. That is what I want to do. So all of these have a 0 living at -1 inside them. So this is almost exactly the same, but we also have a 3 here. And then it is 4 minus -1 is greater than 2. So I'm sort of stumbling upon the algorithm here again. So let's do this one fully in the same way, just to check it works. So I've got a 0 is a 23, which is a 5. And my current dictionary says 0, remainder, searches back to -1. In fact, with these, do I need to keep all of them or just the minimum one? The first occurrence of it. I think I just need to keep the first occurrence of it because I don't care that I saw it at 2 if I also saw it at 1. Is that correct? So hang on, before we carry on up there, let's try 23, 2. That's mod 1. 6. 23, 2. No, that's what we've got. 23, 2, 5. No, that gets 0. 23, 2. Oh no, the 4 is that case, isn't it? No, it's not quite that case. I don't know. It would be quite nice if this here was an 8, I guess. Let's try it with that. With an 8 on the end. So these lines are all identical. Nothing has changed there. 4, we're going to do 35 plus 8, which is 43, which is 1 mod 6. We've got that line there. We can also throw that in with a, sorry, we need a 5, 1. But we've also got the case that if I dropped the 23, 4 minus 1 is greater than 2. Which is saying if I take the first through fourth indices, 2, 6, 4, and 8. No, that is 20. Shoot. That's mod 2. That's 2 mod 6. Have I done that wrong? 7 6s are 42. Remainder 1. Do I need to pair that with something remainder 5? No, I'm trying to undo a remainder. Oh, it's it's these two here. I need to drop everything, including index 1. Okay, so 6, 4, and 8 is 18, which is 0 because it's 3 6s are 18. Okay, so this is, yeah, that's correct. Okay, so I don't need to store all the occurrences. I just need to store the first occurrences. have no idea how to spell occurrences. Is a dictionary. So then what I want to do is for I in range, in fact, let's get rid of all of this junk. Len nums tot equals 0, and this initially needs to start at 0 with a -1. Tot plus equals nums I if tot in mod occurrences let's handle the else for that first. If we've never seen this mod before, mod occurrences tot mod k. Oh, it's tot mod k. I if mod occurrences tot mod k, in fact I'm going to call this tmk, is tot mod k, just because I don't want to have to let it recompute. I don't know if the Python interpreter is smart enough to do this. I minus is greater than 2, true, otherwise do nothing. Okay, I don't want to quite go into the big one just yet, so I'm going to go back to the example test cases and see if we even passed those. Yeah, we do. Right, big one was too big and had to reload the page. Copy, paste. This should be quite a bit faster though. Quite a bit faster. Yeah, there we go. Alrighty, I was going down the wrong avenue for quite a lot of this, wasn't I? But we got there. We got there. I hope. I haven't actually submitted it yet, but I'm feeling much more confident about this because this did drop. What? Zero, 1 minus -1 is 3. That's greater than 2. What? I don't understand why that test case failed. Oh well. This is an easy one to check. Let's do print tot tmk mod occurrences. Show me everything. What even index are we on? 0 is in there. 1 minus -1 is 2. Oh, greater than or equal to 2. Goodness gracious. Greater than or equal. There we go. That was a silly mistake. Boundary conditions on inequalities. Always check them. There we go. Not very fast, but again, I'm not willing to put a huge amount of stock on these timings. A bit of a tricky one again. Again, it's a bit of a dynamic although, yeah, this was dynamic programming because the table wasn't quite what I expected us to be building, but it was a table that we were building. The way to think about it is we're keeping track of, for every mod miss, how is there a prefix of what we've taken that we could drop to adjust for that mod in mod offset that we are? So the idea here is that if we do the 23 plus 2 plus 4, that is a 5, but the 23 by itself is a 5 mod 6. So I could just drop the 23. So we did stumble upon that idea. Whew. But that was a tricky one. That was a tricky one. I think I saw on the main page, this one actually has a fairly low completion rate. Yeah, this one's only at 28.3%, which is quite a bit lower than a lot of the other mediums, and even quite a bit lower than some of the hard ones. So this is a tricky problem. This one's hard. But anyway, quite a nice solution when you get there. That will do it from me for today. Do remember to like, comment, subscribe, all of that good stuff, and I will see you next time. Bye.